Hello, good afternoon, everybody. Hope you're all having a good Sunday. And it's a beautiful day here in Kansas City. A little cool, but pretty nice. I've got a cat in my lap, but she'll probably move pretty soon. Um, I'm excited to get back to our Bevy project today. And I was thinking about last time and how things went last time. And I realized I just don't know enough about LDTK and integrating it with Bevy. So I thought that what might be worthwhile today, rather than going back and trying to integrate LDTK into the project that we already have, um, why don't we work through the tutorial? And um, and that'll give us the right knowledge to go forth and start to integrate it better into our existing project. I think we had some really good things last time, and we just kind of barely touched the surface of LDTK um, and its integration with Bevy. So let's do more of that this time. Let's go deep dive. Let's start with a greenfield project based on their tutorial, and then um, we'll hopefully learn the things that we need to go forward and make our project better. So thank you for coming to the stream today. Say hi if you want, and we'll get started here in just a second. Um, so I'm going to let's see about getting the latest there. Yeah. Okay, I'm going to share this link in the chat if it'll let me. Of course, it's not going to let me. Paste. There we go. If you want to follow along with what we're going to do, I just pasted the link in the chat. And you should be able to see what we're up to. Okay, so I'm going to flip over here. All right, so this is the Bevy ECS LDTK book. This is what we were doing last time. Or rather, we were working with this library, but we hadn't really gone through their tutorial. So we're going to walk through it. They say it is a work in progress, but we're going to do what we can and see what we can learn. Okay, so they're talking about the book here. They're talking about the library. And there's really just a lot of exposition here. But we're going to go directly into this tile-based game tutorial. And then we'll see how far we can get today. So let's jump over to there. All right, so they do have an example in the repository, but I think it's probably worth working through this so that we can see see what we can learn from it without just reading their code. I don't think that's a very interesting use of our time. Okay, so we will need to perform these things. We've got LDTK installed here. It's up and running. We've got our editor. I'm going to make a new window. And we'll add a folder to the project. Let's actually we need to probably make that from the terminal. Yeah. And we'll call this what do they call it in their tutorial? Well, and I've already downloaded this tile set. We'll copy it out of my downloads directory in a minute. You'll need environment tile set and sprite sheets player ping. Okay. Okay, so we're going to let's go ahead and make cargo new. And they're calling it tile based game. Okay. And we can just close this one because we don't need it. And we're going to need to cargo add Bevy and Bevy ECS LDTK. The thing that we need to do with Bevy ECS LDTK, I think, is because we ran into this last time. We need to use the Git version. And yeah, so let's do that separately. Yeah, so we'll use the Git. We'll use the Git repository here. And I don't see any reason why we can't use the latest on this. I think in our work last week, we were just trying to make sure that we had a consistent one across different builds. Not Bevy add, cargo add. Okay. Okay, and it's not liking the underscores, so all right. And let's just run a cargo build and see if it'll build all my stuff. So far, so good. I need to make sure that I've got, yeah, let's make the terminal a little bit smaller while we're on stream. Yeah. Now it's going to build all the Bevy stuff. Okay, so here they're talking about starting off this project. So it's saying this project will have an int grid layer of walls. This is what we tried to do last week, and an entity layer for placing player and goal entities. We'll also have auto tile rules on top of the int grid layer to define the visuals of walls and backgrounds. And this is actually something that could help us based on like the orientation of our grid. We could place tiles in specific ways and also maybe adjust how they fit within and not just like use the 16 by 16. Maybe we can shift them and get like tops of walls and stuff like that. That would be really good. Okay, so note that some of the values here are specified in the tutorial going forward, such as the name, location of the file. So they're basically saying we need to put this in assets, our LDTK level definition. Identifiers for player and goal entities, so grid value walls. Okay. Yeah. Okay, so we have LDTK open. And let's go ahead and make a new project in LDTK, as they say, and call it tile-based game. And we are going to put it in here. And we need to make a new folder, assets. And we're going to call it tile-based game. Okay. So now we've got a new project, as they said. In the World tab, set the world layout to horizontal. So make levels have a clear linear relationship in the editor rather than the geographical one. Okay, so world layout horizontal, one level after the other. Okay. All right, import tile sets. So so here's where we need to get those files into our assets directory. So why don't I copy those over real quick? They were in my downloads. I just got them. So we want to do, let's put these sprite sheets. I'm not okay. Back. Interesting. Okay, so I'm certain. Yeah, these are the individual sprites, which we probably don't want to do. I just want to make sure that we're getting everything in the sprite sheets. Yeah, I think we'll probably need to copy. Yeah, so we've got some props. I think we'll need to probably copy this entire thing in here. Yeah. Okay. Any deads? Enemy deads. All right, let's copy this whole folder. And yeah. Assets. Assets. There we go. Okay, so we're gonna keep copy downloads, Sunny, land files, graphical assets to here. Okay, so now we've got all the files that were in that that package, and they're in our assets directory. So yeah, we'll have the individual sprites, the sprite sheets, which will probably be the most useful stuff, and the environment stuff. So cool. Okay, so make sure the source files, name the tile sets, environment, and player. Okay, so we will go to the tile sets tab. Okay, we've got the world set. Let's go to the tile sets tab. We're going to make a new one, and we're going to make an environment. Okay, so here's the player. And this should be called player. Yeah. And these are 32 pixels. It's fine. Okay. So this looks correct. Yeah, I'm aware. You can go away. Okay. Let's see. Name the for the sign the player tile set needs to have size environment tile set size of 16. Okay, so that's the player. And let's add a new one for the environment. And I'm not sure where this will come from. Oh, here it is. Tile set. Okay. Here we go. This is going to be environment. And those are 16 by 16 tiles. And note that it's also detected the empty spaces. So this is pretty cool that I don't have to do that much here. It already detected the ones that are not, like it didn't make this necessarily as something that we would care about. Okay. So we've got tile sets. Let's save. Okay, we're going to add an int grid layer for walls. So add an int grid layer to the project in the layers tab. This layer will be used to define where the collisions are in the level. Call this layer walls. Make sure its grid size is 16. Finally, give it an auto layer tile set pointing to the environment tile set. So we're going to figure that out. So layers, we're going to make a layer integer grid, and we're going to call it walls. Size 16. And I don't see this auto layer thing. This is probably a different version of LDTK. Grid values, and they call that wall. Okay. auto layer tile set. Here we go. Environment. And I'm assuming the next thing we'll do is do edit rules. Okay. Opacity. Yeah, I don't see anything in here that's like, other than the layout of this UI, I don't see anything in here that's very different. Okay. So let's save. We can close that. So from the walls layer definition, select edit rules for the auto layer tile set. Okay. Rules. Okay, select plus group and add a new empty rule group. Okay, empty. And name it background. Rename background. Okay. On the new group, select plus to define the first rule. Excuse me. Okay, plus to define the first rule. In the top right of the rule definition, select the tile you want to use as the background. Since this is a catch-all rule, no changes to the rule pattern are necessary. So individual tiles. I don't see our tile set in here. First, pick which tiles you'd like to automatically render. Okay. So, okay, so they picked this dark color. Any value, no value. I don't see this one by one. Here, oops. Rules. Okay. Rectangles of tiles, individual tiles. All right. I don't see anything different that we're doing here, other than that the UI is different. So okay. And what's this check mark thing? That's the only thing I'm seeing different here. Okay. Next, define a rule that will catch any wall tile. You will be able to define more complex rules on top of this to make the walls prettier, but it's good to start with a generic one first. So create another group and name it walls. Walls. Okay. Click on the plus on walls group to create its first rule. Select the tile you want to use as the generic wall tile in the top right, and they're using this brownish purple thing. Left click the rule pattern to place a wall tile. Okay, so we'll select, this is their brownish purple thing. Yep. Okay. And I don't know where this random tiles, I'm assuming this is individual tiles. Yeah, let's do that. Or it might be that. They look very similar. Okay. Now you'll be able to place walls in your level and they'll be automatically rendered using this tile. Okay, the following rule is optional and will define the tile used for the edges of walls, specifically horizontal edges. Okay. So create a new rule in the walls group It looks like they're doing it above, so it needs to be before. Okay. Select the tile you want to use the left edges of the wall. Okay. Left edges of the wall would be that. Is what it looks like. Okay. And then say rectangles of tiles. Okay, so that would be, we don't want individual tiles. We want rectangles. So this would be left. I'm assuming what we're going to do is do the same for the other spots. So for this one, we will pick top. For this one, we will pick right. For this one, we will pick the bottom. Okay, hold on. I may have gotten ahead of myself here. Okay, what are these rules from most specific to least specific? So the rule matcher will result to catch all rules last. Okay, so I actually got this wrong. I think I need to say, because this is only this should only be the left. Let's see if you can select more than one. No, this is the left. Okay. And you can't really name these rules. So I think I'll make another one, rectangles of tiles, and this would be like, you know, they're showing here vertical wall edge rule mirrored in the y direction. I don't understand what that means. There's this 3x3 thing, which looks like this. Okay, so we are fighting with a little bit how this is. That's just this display. With how this is different from what they have in the tutorial. So maybe we're missing some things here. But we'll figure it out. The main thing here, I think, is sort of like I want to get familiarity with this editor and how it will affect what we see in our Bevy application. So, okay, so we have a top, we have a left, and maybe we do a corner. Okay, so they're showing you can do inner corners and outer corners. Maybe what we can do is like shift or control or alt command. No. Yeah, so this should be the top. And let's make a new one. And let's pick. Let's pick this top left corner. I'm not sure what this is. Like, I have no idea what this thing. What this does. Okay, so interesting. We're getting some stuff displayed there. Maybe this area, this is like, maybe this has to do with how we are picking the rectangles of tiles. because it is down in this area. And note here that they were selecting only a single tile. Oh, so okay, so we're getting, yeah. Let's go back and let's delete these and start over, because I think that I didn't understand the what this is, and it's not letting me select. So let's pick the left wall to start with. Okay, so it's not, I'm guessing this has to do with something, but let's look at what they did on the left wall. Okay, so we put the X here. So that's where that one should go. And they're not picking rectangular tiles. They're just like random tiles out of a selection, but there's only one. So, okay. So that sort of makes sense. And I think that we do that. So note that is filled in with black. It's not the cross-hatched. And this is filled in with the X. I think that's what we're going for there. Okay, let's make a new one. We got to fill in that. We're selecting the top. So, oops, not that. We're selecting that. And we're putting the X there. Okay, so vertical wall edge rule mirrored in the Y direction. Okay. Let's make another one. So we're redoing this. Okay, so this is a corner. And it's looking like they're saying this is what it should be when there's not. Okay, so maybe the X is about where there is not something of this int grid value. So if the black one is where we have filled in the value on the integer grid, this is saying here's one where it's not, so this is what you pick for this tile. I think that's what it's saying. So we will fill this in. We're doing the top left corner, right? So that would make sense that there's not one here and there's not one here, so we should have we should use this top left corner one as the tile there. Okay, and this is like, oh, okay, so we have an inside corner. There's a value here, value here, value here, and this, but this one doesn't have that same value. Then we should use this tile. That's what they're, okay. So I think I'm getting it, the hang of this. It's a little complicated because they don't explain everything. But we'll pick that one. And so we have a wall there and a wall there and a wall there, and we don't have one there. So that's the bottom right corner. Okay. So now you can enjoy placing walls in your level, watching LDTK auto tile them for you. Hopefully I have my sound turned off. We'll turn it way down, off, and see what this video does. Okay, so they draw. Well, that's interesting. Let's see if we get a similar outcome. Okay, so we're on the walls layer. Let's draw. Okay, we're getting some. That's interesting. Let's draw that inner corner. Yeah, so we got that that G scroll thing on the inner corner. That's interesting. This should, if this works out and I get to understand it correctly, this should help us a lot with the auto painting on our other project. So yeah, note we got that corner there. We're getting the left wall. If we do this though, we're getting the left wall. So I think that we need to do some more rules there. yeah, I don't think it was automatically. Um, I don't think it was automatically mirroring. Uh, okay, so that's what the X and Y. Okay, so let's fix those rules and maybe it'll look better. So this one is mirrored on the X. Oh no, not that one. This is mirrored on the X. And it's still using that tile. Um, interesting. Also note that we're getting things not shown. Okay, so mirror on the X. Works for the right edges of the walls too. And the top of the wall is mirrored on the Y. And right, and this is mirrored on the X and the Y. And so is the inner corner. Now that's kind of interesting, like right there. We put that there and it flips the tile. What's weird though is this doesn't flip the tile. Okay. And also I think that we're getting this inside corner when we should get the outside corner. So maybe we don't mirror, yeah, because otherwise we're getting, and this, I guess there's a thing here. Maybe what we want to do is make this rule be above this one. That doesn't work. Yeah, so if we mirror in only the X on this, some interesting decisions here. I think that, you know, the tutorial is probably not going to cover everything. And yeah, see, they've got some weird anomalies in their example too. Like, you know, that's upside down. There's, it looks like a corner there. Yeah. Okay, so it's not going to be perfect. So maybe what we could do is let's just delete everything and let's draw a except it's not drawing a rectangle. I wanted it to draw a rectangle. Do I have to hold shift? Yes. Okay, so there we're actually getting, because I didn't draw individual tiles, I drew a rectangle. So like this inside part is yeah. What's interesting here too is that even though I just deleted that using the right click, it's still filling in with this. So rather than the background. I wonder if we need another value in this. Let's go back up and look at the background. Right, so they have it deselected. So let's look at this rule. Right, so it's deselected. So if it's not in the wall, I mean, do we do that? Will that fix it? No. Then we should get that color, that tile, but we're not getting it. Let's see. Oh, that's the problem. This Okay, so now we're getting the background, and the inner part is this this color. Okay, so it was the problem with this bottom rule here. Okay, cool. That's good to know. That'll mean that we can think about how to structure our level design for the tiny dungeon based on this. That's a huge help. I'm glad we learned this. Let's keep going. So we've got through defining the wall tiles and mirroring. Yeah, so let's go to add an entity layer. So add an entity layer in the project and layers tab. Okay, so we're gonna close that. Layers, and this is gonna be entities, and we'll just call it entities. Match the grid size of the walls layer. Okay. Okay. We don't have to do anything there. So we go to the entities tab, and let's add, this is going to be the player. Okay, add an individual rectangle. And we are using the player tile set. We'll pick the first tile, fit inside bounds. Okay. Right, okay. I don't think that we're doing anything else there. Okay, so let's make the goal. And this is going to be from environment, and we'll pick this thing. Fitted size bound, inside bounds. Okay. All right. So in the following chapters, you'll spawn this project in Bevy and implement gameplay code for it. The game will be simple. Move the player around the grid, navigating the walls, and start the next level once they reach the goal. Let's mind design a few levels for this game using the tools you've set up so far. Okay, so we have kind of we've kind of made this already. I'm going to extend this a little bit. And maybe we'll do this as well, and like, I don't know, put the player here and put the goal there. So let's go ahead and on the entities, let's place the player right there, and let's place the goal there. Okay. Let's save that, and let's see. World view, create a new level. Okay. And current level. Let's pick the walls. And we were going to do something like a, oops. Oops. We're just drawing some stuff here. Not particularly interesting, but and let's select the entities and put the player here and the goal here. Okay, so not particularly interesting, but we'll have at least 2 levels. Okay, so let's go to the next step. So we already created our Bevy project. It has these assets down inside it. And let's look at main. And typical to projects we've done before. We're going to use Bevy Prelude, and then we're also going to use Bevy ECS LDTK. I'm going to trip up on that a bunch. Use their Prelude as well. Okay, and then our main is going to be app new. And Rust Analyzer is taking a while. Okay, so we're going to add plugins. There we go. Now we're starting to get some help. Default plugins, set image plugin, default nearest. So this is something we could do on our other project. Is rather than using linear filtering for the images, we can use nearest neighbor, which will give you that like pixel perfect look at the right zoom level, at multiples of 2 zoom levels. I suppose on like our partial 75% zoom that we did, we add plugins, LDTK plugin, and our run. We probably were better off with a little blur. Okay, and this is not following the kind of pattern that we did in our other one, but let's just go with what they were doing. So they're going to spawn the camera and the world bundle. So let's do add systems, startup, setup, and we need commands and asset server. I'm just going to copy those. Okay, so they make a new camera. Okay. Interesting that they do it that way, but because I think the translation is by default 0, 0. Okay. Equals camera 2D bundle. Default. Okay. Camera dot projection dot scale. And remember, if I remember right on this, the scale, it actually, smaller numbers makes it look bigger. So that makes sense in this case. I think they're trying to make the sprites bigger. And then we'll just copy this. I don't see any reason to type it out. This stuff we've done before in previous streams, manipulating the camera. And then we did this last time. So okay, and then we need to insert the level selection resource in main. Okay, so let's cargo run. I don't need to know that we need to do run release mode. I'm going to steal this, which I actually put in a project at work the other day, because we were like, why is this running so slow when you're developing locally? Well, you know, if you don't optimize the packages of your dependencies, the crates on your dependencies, then you get it can be more slow than it should be in debug mode. Okay, so let's do cargo run and see what we get. Okay, so it's going to download all the stuff, compile it. And hopefully what we'll get is our level that we created showing up on the screen. And then if we set it to 1, we should get the other level showing on the screen. And it's probably doing this because it has to recompile at that higher optimization level. What's up, Chris? I love it when you come in with the dancing dinosaur. That is fun. So if you just joined us, Chris, we are working through the Bevy ECS LDTK tutorial. Mostly because last time I jumped into it without knowing what the heck I was doing. Hi, Tuxified, welcome. And we're going to try out their tutorial. And we've already learned a lot about LDTK that I did not know, and I think that that's going to improve our level design for our Survivors game, as well as simplify a lot of things. We don't have to hand draw it. And we are compiling everything. Cool. So let's see what they'll want us to do next. So we'll be spawning sprites for the LDTK entities. So this is probably one of the things that we missed last time as well, is bridging between the entity definitions in LDTK. Yes, I saw Chris. I saw your video on the Blender plugin. That looks really freaking awesome. So if we were doing a 3D thing, I would be all over that. You know, I think people maybe take for granted the fact that things like Unity have an editor that ships with the framework, and Bevy doesn't have that sort of thing. So having a 2D one and a 3D one is really, really nice. Almost there. Okay, so there's going to be a sprite sheet bundle for the player and one for the goal. And then it looks like you do this to link up the names that are in the LDTK file with the bundle that they represent. So that makes sense. This does feel a little bit manual, and it would be nice if you could put it here, like in the derived definition, or with some marker, but that's okay. Not a big deal. Okay, so our level we just created showed up. That's pretty cool. Can't do anything with it. But it is displaying, and it's displaying at the zoom level that they said. And note here that we're not getting any blurring on the, maybe hard to see on the Twitch, but we're not getting any blurring of those pixels. They are like crisp. So that is good. Okay, so let's go forth with this section. So we need to create some bundles here, and like we were doing earlier, we'll just do this directly. Default bundle and LDTK entity. Okay, struct player bundle. Probably doesn't need to be pub because we're just using it here, but yeah, we're not putting this in its own module. Okay, and this is sprite sheet bundle. I'm assuming this is a marker for the LDTK derive. Right. And it's basically the same thing for the goal bundle. Okay. Goal bundle. And this being a bundle means that it's not actually something that we'll see in our queries, but we will get all the things that this sprite sheet bundle includes. And I'm assuming that this derive will inject the appropriate sprite sheet into this bundle when it's created. So, you know, the texture atlas, the sprite, all of this stuff. Okay. And then we do this. So I kind of would like to move this above our startup system. So we're getting the resources first. Okay, now let's run it again, as I say. And see, we got our goal and our player in there. as they described. So this was what we saw over in this. No, not new level. Help me move, please. Okay. Pan. Can I pan? Okay. So there's our level. The player was put there, and the goal was put there, and that's what we got. Cool. Okay. Let's try level selection 1, and then we should get our other level. Yep, so we got our other level. Our guy's down here. There's like some clipping. It should be arranged differently, but cool. So let's put it back to 0. All right. Okay, so we got the sprites displaying. So in this section, you will integrate gameplay to the Bevy LDTK project created in the previous sections. This includes tile-based movement, collision, level transitions. Okay, so we specified the in-grid value of walls is 1. So we need to add a marker component and grid coordinates to the player. Okay, so let's minimize LDTK for now. This is pretty straightforward stuff that we've done before. Component and debug. Struct player. Okay, so this is how we would do probably the same thing in our own project. Is to have we had those various marker components, so we would make a bundle, and this needs to derive default as well, and put our rather than having those tuples of things, we would have the LDTK define those things, and we can spawn that with just the bundle based on the level design. Okay, and we need grid coordinates in here too. Grid chords. Okay. Right. Okay, so this is a simple, you can only be on the grid type of thing. That makes sense for now. So let's make that system. We'll go ahead and add it. So on update, move player from input. Move player from input. And this is got to have, players is a query. Mute grid chords, and that's with player. All right, so they're using that marker component that we had added to the bundle, and then we're going to take the input is the key code. Okay, and right, so I'm just going to copy this. That's not that interesting. They're just looking at what is the key code. I guess it could have been like match key code, but it's fine. This just pressed is probably the most straightforward way to do that. And then we're looping over the player grid chords. That's in players.intermute, and then we're going to modify. I wonder if grid chords has what is the add assign. Let's see if it does. Movement direction. That's a little bit easier. this needs to be mute. Okay, so yeah, it doesn't. I'm guessing it doesn't have add assign on it, so we need to do let destination, as they do in their example, grid chords plus movement direction. Okay, and then I imagine we need to deref that. Yeah. Okay. So I'm assuming that there's a problem here with grid chords doesn't implement add assign. So what we'll do is player grid chords equals destination. That's interesting that they don't have add assign on it. Okay. So right, so they're saying if you play the game at this point, you notice the player entity doesn't appear to be moving at all. The grid chords component may be updating correctly, but the entity's transform is what determines where it is rendered, right? So this sprite sheet bundle has a transform in it. So I'm assuming that this derive, when it pulls in the entity and it loads your level, it's going to assign the transform based on the coordinates defined in that level. For the player's initial position. So their next system is about yeah, and I think we could probably put chain on that even. But it would be like if you have a transform in grid coordinates and I see, change grid chords, then you'll use their utility to translate it. And grid size is 16. Okay, so that makes sense. It's similar to some code that we had handwritten in our own app. But it's kind of nice that comes with the package here. Okay, so let's go ahead and make that system. And this is translate grid chords entities is what they called it. And they didn't do a chain on that, so it's interesting. I haven't actually written a system that has the changed marker, and I wonder if this is out of date, but I don't think so. These, and this is going to take. I think it's really tedious to name that variable so much. They're so long. Okay, so this is going to need a mute transform and grid chords. And we want that to have changed grid chords. So I guess that still is a marker. Yeah. So added or mutably dereferenced after the last system ran. So simply mutably dereferencing a component is considered a change. Does not compare components to their previous values, right? Because there's no equal or partial equal on these things. So it's like, did you deref that thing? And that's why they have that special mute wrapper. You see here, that's not an actual mutable reference to the grid chords. That's like a guard type object on wrapping that grid chords so that they can detect when you deref it. Okay, and then what else did it take? I think that's it. Yeah. Okay, well, let's go ahead and make this. What's wrong there? I'm not taking that owned by ownership. That's the problem there. Okay, cool. So then we're just gonna use that. That makes sense. So for transform grid chords, and this needs to be mute. Remember, in entities dot iter mute. Then we're gonna say transform dot translation. Right, and so we need this grid size, which is interesting that we can't get that from grid size I32. We can't get that from the level definition. I wonder if there's a way to do that. Obviously, they're going to skip over that a little bit in this tutorial. But let's copy this because that's a little complicated. And let's look at what this does. So we may go into this function and see how it works. Okay. So the essence of this is we're changing the translation of the transform, something we've done before. And so this is a function that takes the grid coordinates and your tile size and gives you a vec2. And then we're adding, the z to it that was there previously. So extend being turning a vec2 into a vec3 by giving it a value for z. We've done this before in our other project. Okay, so that's pretty straightforward, and let's just jump into that function. Okay, so this function we may need to look at. It's right above. Okay, so you can turn the grid chords into an IVEC2, right? Your tile size is, this IVEC2, and then converts it to a float vec, and that's pretty straightforward. So, and it looks like what they're doing here is that this would be probably the coordinate system on these vectors would be bottom left is 0, 0. So if you add half of the tile size, you're getting the center of that thing, which is what Bevy's coordinates would be on. So that makes sense. Okay. Looks like there's some other, here, let me go back there. There's some other interesting functions in here. So you could take, yeah, that's not right. Not what I was thinking it was. But these might be really useful for us later. Okay. So now we will run that and see if we can move our player around with WASD. Cool. So they move very chunkily. Note that we can make them move over walls. So that's something that we won't want them to do. But we can move that around pretty easily. Cool. So those systems are working. Let's soldier on. Okay, prevent tile-based movements into walls. Movement works logically and visually now. However, you might notice that you can move into the walls of the level, which we just saw. To implement tile-based collision, you need to add components to the walls to identify their locations and check against these locations when trying to move the player. Okay, so let's do what they show here. So they have a marker component for a wall, and they have a bundle, and this goes from the int cell. And note it says int cell 1. Okay, so let's start with that. Default, we need this marker component default debug, as we usually do. Struct wall. Default bundle LDTK entity. No, it's not entity, it's int cell. So this is the layer type that we were doing in the editor. And we'll say struct wall bundle. And we put the wall in there. Okay. And then we need to register that type. Int cell 1, and that's going to be the wall bundle. Okay. So, okay, there are a lot of ways to go about implementing collision systems. Naively, you could query for all the wall entities every time the player tries to move and check their grid chords values. In this tutorial, you'll implement something a little more optimized, caching the wall locations into a resource when levels spawn. So we create a level walls resource for storing the current wall locations that can be looked up by value. Give it a hash set of grid chords field for the wall locations. Give it fields for the level's width and height as well, so you can prevent the player from moving out of bounds. Then implement a method in wall, giving grid chords, okay, on the resource. That returns true if the provided grid coordinates is outside the level bounds or contained in the hash set. Okay, so we'll make a resource and, derive default resource like we've done previously on some things. Derive default resource. I'm getting the sense we're kind of getting toward the end of this this tutorial, and we can probably put some of this into practice real soon. So wall locations is going to be a hash set of grid chords. Okay, and then level width is an I32. Wonder why that's signed. Level height is an I32. Okay, we'll add our init resource up here. Okay, and we need to import that. Nope. Import. I think it's just standard collections hash set. We'll do that for now. Yep, that's what they used. Let's convert that to qualified path we used. Okay. So then we implement this in walls. Oh, got my fingers on the wrong keys. Impl level walls. Fun in wall. This takes a self, and chords is grid chords. Grid chords. Yep. I really don't like this naming convention, but we will be consistent with them for now. Okay, so if the grid coordinates are less than 0, right, so this is testing, is it in a wall? So if the grid coordinates are less than 0, or the grid for X or for Y, or they are greater than the level width, same for height, so those are all the quick check conditions. Are you outside the bounds of the level? And then there's or wall self dot wall locations contains grid chords. Okay, so that should be fairly self-explanatory. Yeah, heck, quick check. I say quick in the sense that the OR here is going to be return early, not in the sense that it is a property-based test. Okay, and we just wrote basically what they wrote. Okay, so now we need to do this cache wall locations, um, and this is going to be a little bit more complicated. It looks like. So let's add that to our list of systems in update, and let's make that system. Let's see what they do. Okay, doesn't do anything yet. Okay, so they take the walls, the level, and this is taking this resource mutably. So I'm guessing that based on the other things in here, right? So they're reading level events. So if the level changed, then we need to update the walls resource. And then we will take, okay. So we'll take all the walls, all the grids that have wall marker on them, and then we will take, it looks like the project entities and the project assets. Interesting. Yeah, let's I don't know why we need those, but we'll find out by implementing this. Okay. So I understand why we take the walls and the event reader. So we're going to loop over the level events out of this reader, like we did last time when we were decoupling some of our collision systems, by sending collision events and then reading the events and checking them against various queries that we care about. This would make sense that if this level event is like the level changed, then okay, so it's an enum and it has spawned triggered, spawned, transformed, and despawned. So I'm guessing spawned is the one we care about. Then it would be, yeah, let's see what they do. Okay, so this is what we expected. They're going to loop over all the events. So let's start with that. Okay. And then if the event is spawned, so that's sort of what we expected. I want to say, no, I think that's only on nightly. There was one where you could do for let. Pretty fun. Put the filter in there with your loop. Okay, so we've got the event, and this level is spawned with this ID. Okay. So they're getting the project asset. And they're getting, so we're expecting this to be a singular LDTK project. That makes sense. What's interesting to me is that there's this assets resource for this, and there's a entity that has the handle for it. I suppose that's not that weird, given that we, for instance, in our other project, when we were loading an image as an asset, you'd get a handle to that image. You don't get the actual thing. And then the assets would be this, would be the wrapper around the original thing. Okay, so okay, so this is getting the actual asset using the handle. Using the handle to this LDTK project. Okay. Okay, so that, I don't know what they're going to do with that yet, but let's go ahead and add that here. Okay. And then we're getting the level. Okay, so the project contains the information about the levels. That makes sense. So we get the raw level by IID. So that's the ID here of the level that was spawned. Okay. So far, so good. Um, okay, so the wall locations is like, where are all the walls? Okay, so what this is telling to me, uh, we only care about the LDTK project to get the levels dimensions. But when this has been spawned, all of the wall entities are already in the world. That's what I'm getting with this. So that makes sense with what they're doing here. So this is, there's no types on this, but this is basically saying take all the grid coordinates that are marked with wall, iterate over them, copied, because I'm assuming grid coords is copy rather than cloned, and then collect them into a hash set, because we know that the field here on level walls is a hash set. So that makes sense. And then they're creating, so let's copy that in. I want to type that. Right. So yeah, and that makes sense that that's copy. It's only two I-32s, not a big deal. Okay, and then they're making new level walls out of that, and this level has a field px wid px high. They couldn't even name the thing with a full name. Oh, and then we have this grid size. So they're saying this is the pixel width, which I guess makes sense for the case of if you have tiles that are of different sizes, then you would want to store the absolute width of the level in pixels. That makes sense, rather than grid units. Okay, so then what we'll do is we'll deref level walls and assign it to new level walls. The other thing that we could have done is, and I guess it doesn't matter, there's probably some reason for it. Oh, wow, I'm really good at this. I don't know why you would create a new struct rather than modifying the existing one. Maybe there's some memory locality things. I don't know. But that hash set is going to be on the heap anyway. It probably doesn't matter that much. But they're basically replacing the whole thing rather than changing individual fields of it. I don't know. Stylistic thing. Okay. So one thing that may be interesting is that remember in our editor, which I minimized, this is all inside the wall. So I'm assuming that this is going to be like, once your player spawns here, you can't move. We'll find out. Okay, so then they're going on to add this level walls resource to the move player system. And then you can only move if you're not inside a wall. So they use that method that we created on this resource to check if you're not inside it. That's a pretty simple change to make. So we'll go up here and we'll say walls, res, level walls. Okay. And then we'll put this if not walls dot in wall destination. Then we'll move the player. And I'm suspecting that given how we drew that level, we won't be able to move. But let's try it out. Yeah, because what we did here is this is the background, and we drew a rectangle of walls, but we didn't hollow out the middle. So I'm pressing WASD. I don't know if you can hear that, but our player's not moving. Now, if we switch level to to 1, which is where we drew that kind of spiral level, you can see we can still move because we're on background. So, but I'm pressing down here and I'm not going through the wall. I'm pressing left and not going through the wall, and so forth. So maybe what we should do is go back to our editor and fix that. And we're going to pick layers wall. And I'm going to remove the inner part. And we'll save that, and let's rerun it. And I need to fix the level that we're on. Okay, so now we can move, but we still can't go outside the walls. So I think we're doing okay there. And yep. Okay. Okay, let's do their next step. So trigger level transitions on victory. The final step is to implement the goal functionality when the player reaches the goal, and the next level should spawn until there are no levels remaining. Okay, so now we're going back to the goal bundle that we created originally. And there's no, there's no marker in this, so let's go ahead and put that marker trait, or that marker component, rather. And struct goal. Okay, and then it also gets a grid coordinates. So that will basically because we registered that with this name up here, that's the stuff that will be spawned for that entity. So we don't really have to do anything there, but we need to do this check goal. So we'll do check goal. And let's look at what they write here. So it takes the level selection. So this is the level selection that we added up here. We started with 0, right? And then you have the players. So if they moved, so the grid coordinates of the player, if they moved, the grid coordinates changed. And then the grid coordinates of the goal. And let's see, so they're zipping. That's interesting. They're zipping the goals with the players. There should be only one of each. Okay. So if the player's coordinates and the goal's coordinates are the same, if any of them are the same, then we bump the level. That's what it's saying. It's an interesting way to do that comparison. I might have done something like cross product, but like given that there's only one goal and there's only one player, and we don't have anything like player enters the first goal and they get transported to like some doorway and then they have to find the next goal. We don't have anything like that in our game, in our tutorial game yet. Really, I would probably do like player.single and goal.single. But this is fine, I guess. It's also a possibility if you had a game with multiple players and multiple goals, and you spawn them in the correct order. That might be a little tricky. You would have the possibility of each player having their own goal to reach. I don't know. That could be another reason why they do it or zip here. But let's just go with it. There's not a big deal. This is just a tutorial project. So check goal. So we need the level selection, which is res mute level selection. Okay. And then we need the players. And I'm going to see if I can do this without remembering exactly what they want. They want the grid coordinates of with player. And it just changed. Grid coordinates. And then we want goals. I missed a bracket there. There we go. And the goals are query of grid coordinates with goal. We don't need anything else. Okay. So here, let's do their thing. So if players.iter .zip goals.iter any, and so that'll give us a tuple inside this iteration. This is the player, I'm going to shorten it, player coordinates and the goal coordinates. And we just want to see if they're equal. Note that it figured out what those types were automatically. This is why I love Rust. Oh, not grid chords, goal chords. Okay. Okay. So if any of them are equal, I might do this one with a let else, because this is kind of, maybe this was written before we had let else. Okay, we're going to say let level selection indices level selection dot into inner else panic, and I don't actually care what the message is right now. They put a level selection must always be indices in this game. Like, I guess we can put that in here. Fine. And then I think we need this to be mute. And then that's indices dot level plus equals 1. I think that's a little better. That's my personal taste. You can disagree. But so now what we should be able to do is we should be able to walk the player around. They step onto the goal and they get moved to the next level. So let's give that a try. Okay. Did I not add it? I did. So what did I do wrong? Did I not save something? Let's compare our systems here. Maybe I made a mistake in the system. Okay. Right, so we're getting the grid coordinates, the player, and the grid coordinates changed. There's maybe, I want to do this, I think. Let's put chain. That will ensure that we do these in order. So we, well, it's not strictly necessary. This cache wall locations could happen at any time. But we want to check the goal after we've moved the player. Let's try that. So we did not get that to be changed. Let's look again at their system here. So interesting that this doesn't need to be mute. The res mute doesn't need to have mute marker on it. Did I do anything significantly different here? I don't think so. Other than the let else instead of the match. Maybe I can leave that off. Maybe it's already a reference. Yeah, it's already a mutable reference. Let's see what their video shows. Okay. Well, we may have reached the limit here. I'm wondering if I did not. No, the goal bundle has the goal component on it. I'm not sure what we're missing here. Okay. Well, I feel like we learned quite a bit. What will be interesting is going back and rethinking our survivors game with this sort of design in mind. You know, like generating the walls with rules looks pretty cool, and I think that we could do that pretty easily. We might want to oh yeah, because I think on our previous version we had drawn the walls and then we put an grid layer on there, and then it displayed the red color of that grid, rather than putting a tile on there and it displayed above the thing we'd drawn. So it was kind of like, I think, the wrong way to go about it last time. So maybe we can flip through here real quick and see if there's anything else we can learn. Obviously, there's this level selection resource is something that you have to have. Excuse me, and you pick it by number. The level set has a bunch of UUIDs, looks like. Yeah. That's not something I would probably want to do. As long as it's linear, we can just keep it to be numbered. Right, okay. So the level set is what level selection uses under the hood. Not surprising. You may recall, and it looks like I quit LDTK, but in LDTK, when we created that world, it gave it a UID, and I think that like layers got a UID as well, or levels rather. So would look something similar to this. Okay, let's look at these components. So the entities you define in your, we saw this in our tutorial we did earlier. The entities you define in your level editor can be mapped to the components that you build in Bevy by giving it a bundle and selecting it by name. So we can do that with entities and int cells. So you need to spawn children, or I need to access more resources of the world. Okay, does not have be spawned with the entity instance component by default. Okay, so you could do something like this. It looks like, so if you don't define that derive like we did in our tutorial, um, you could at startup loop over these, um, and and convert them into the stuff that you want. Okay, so you could choose like a different sprite. Um, you could add the marker entities that you care, or the marker components you care about. Makes sense. Um, right. So I'm guessing that like this is the sort of thing that those derives do for you under the hood, and you don't have to do it yourself. Okay, so let's look at this. A blueprint pattern. So if you combine the approaches, you register an LDTK entity install with a marker component. Querying for it later won't require filtering for a particular entity instance identifier. Plugin does that for you when giving you the entity your bundle. Then you can write queries that filter for the marker component instead of entity instance or in grid cell. If you add the transform overriding bundles within the entity bundle, you won't need to tiptoe around the transform your post process. This is okay. So I don't completely understand what they're saying here. Let's read their code example and see what it says. Okay, so there's on update process player. So on a command, so we've got commands to be enqueued. If players are added, so there's a new, you're getting the entity and added a player. So this player is this marker component. It's in the player bundle, and that's registered to for these LDTK entities called player. Okay, so for the entities in the new players, spawn a child component. All right, so this is like you still have the bundle, but you want to modify it after it's spawned, which is to add a child component, or you add this entity which it has a component player child on it, and then you set the parent of it to the player, the entity that had the player spawned by LDTK. Okay, so if we had something like let's say we define our player entity as the knight, that we did in our survivors game, and when it's spawned, we want to give it a child component, which is like maybe has, or a child entity maybe has a shield, and like we want to display that shield over the top of the other sprite, and so that should be positioned relative to the parent entity, which is the player. And so we would spawn the shield, for instance, or a shield bundle because it would have a sprite in it, and then set its parent to be the player. Like that might be an example of what you might do. Probably a bad example, but okay. Let's look before we wrap up for today. Let's look through the rest of these pages. I think the level selection was pretty obvious. We played with that a lot. This is interesting to know about. Anatomy of the world. Okay, so when a world bundle is spawned, levels are selected and associate assets finish loading, the level spawning process begins. Okay, so this is probably about details about how it spawns. Okay, so there's the world bundle, the level entities, which, okay, so these are child entities of the world entity. So they're levels, and they have the level IID component. For entity layers, a layer entity with just a layer metadata component. per interesting. Okay, so the instances of the entity. This is the thing we saw when they were like, if you want to customize out loads. Okay. And then for tile, auto tile, and int grid layers, these are Bevy ECS tile map entities. So this is the magic that happens underneath. We could have used this crate directly, but we're not. So it's probably, something we could have looked into, but I like the idea of having a level editor. I don't know about you, but like it'll make so many more things easy. Okay, so it has a tile map bundle layer metadata. So the tile entities have int grid cell components, or others if you're using that. For tile auto tile layers. Okay, tile bundle. So this is basically like this is the contents of what is inserted into Bevy's ECS when you load the world. Okay, so this allows you to find entities are worldly. The intention is features support entities that are allowed to persist and traverse between levels like a player. Okay. It changes its placement in the above hierarchy instead of being spawned as a child of the entity layer entity. Worldly entities will be children of the world entity after one update. Let's see what that links to. We'll see. Let's open that link in a new tab. Okay. Oh, so this would be like if you broke up your. So they said a Gridvania, so like a Metroidvania type game. If you defined like each of the rooms in your Metroidvania as a level, then what you wouldn't want is when your player character moves from room A to room B, they shouldn't spawn in that room at an arbitrary spot. They should spawn at like the door they traverse through, right? So I think that's what they're talking about here is that the worldly entities can move not independently, but like they will not be a new entity when they get into the next level. Promotions not go away. That's not appropriate. Thank you. So this would be it's just a marker. It looks like that you can put a marker component you can put on your entity that says this thing should be not respawned. It should not be despawned and respawned anew. Okay, so that's what that means. Worldly entity. You're right. Okay, so then there's metadata about the tile set. So if we put any tags or anything on the stuff in our editor, those would be available in the entities. So level backgrounds, supply background color and image for individual levels. It renders them by default. Background color is spawned as a normal Bevy sprite bundle as the child of the level entity. Okay. So if we wanted to put richer backgrounds on our level, we could do that. Okay, it is possible for LDTK tile auto tile layers to have colliding tiles. In other words, a single layer can have more than one tile in the same location. And I think we saw this on one of their examples. But ECS tile map allows only one tile per position. So it supports layers with colliding tiles by spawning multiple tile maps. Each of them will have the same layer metadata component. This means user cannot assume that there will be only one layer metadata entity per layer. Okay, so you might be able to like overlay tiles, is what they're saying, and that would be different tile maps. And I'm assuming that on an entity that's in these, we might have this layer metadata. We may have to look into that in a future episode, a future stream. Okay, and Zeter, to correctly define the render order of tiles and entities level, it uses the Z value of their transform components. Z order is only applied to level backgrounds layer entities and worldly entities. Hello, welcome, Zakar's Dab. Welcome to the stream. So tiles and non-worldly entities simply inherit the Z order in the global transform. Okay, so you get a Z value of 0 for most background entities, increments this by 1 for each layer above that. So in the editor, and I'm sorry I closed it. So in the editor, if we look at the layers, the entities are on top and the walls are below. If we had like a background layer or a like, I don't know, another layer that had some terrain or something in it, the order given here in the project layers is the Z order in it's the Z order in the entity component system. So the transform. That's what I think that's what they're saying here. Right. So it's saying don't make assumptions about the Z value. That makes sense. Okay, we have about 15 more minutes in my plan for today. I think this make level selection follow player is probably about making a Metroidvania type game where each level is a room and you move between rooms and so forth. Let's look at this one because I don't know what it is, and then we'll probably wrap up. And next time we'll be able to hopefully have a more principled approach to using the editor and then pulling that into our game. And we'll probably have to refactor some things to make that possible, but it should be it should make a lot of things a lot easier, I hope. So, all right. So create Bevy relations from LDTK entity references. So they're talking about LDTK entities here, not Bevy entities. So you can point to other entities using a field. This is now so a component on one entity serves the entity identifier of another one. Okay. So this might be something like you have a button entity that opens a door, and there's a relationship between those two things. And so you can have a field on this button that points to the door that it opens. That makes sense. Okay, so looks like this is a little bit complicated. Okay, so it looks like you have to create something with an empty identifier in it initially. Okay, so and this entity instance is the thing that is coming from LDTK. This is not a Bevy entity. This is the LDTK entity. So they're saying here, yeah, you're getting a field off of this entity instance called mother. If it doesn't have one, then it's going to panic, and then it's going to take a reference to it and then create. Oh, so they're going to clone the ID of that LDTK entity and stuff it inside this component, inside option. It's interesting that this is option when they're doing expect here. I would think that they wouldn't do expect. This would be like as ref if this returned none. So that's a little weird. I think that might actually be a mistake in the documentation. Unless this returns like result of option or something like that. Maybe we should look at that in their docs in a minute. Yeah, I don't have it up, but we can look at it in a minute. Yeah, because this is basically unwrapping that, so it would be the actual entity ref. Anyway, okay, so then you put that on the bundle, and then you use this to um, extract, to create this component, right? Okay, and that's that with uh, attribute comes from the bundle derive, not from LDTK entity. Um, if I understand correctly. No, I'm sorry, that's wrong. It definitely comes from this because bundle doesn't know anything about this kind of function. Okay. And then it's saying resolve reference in post processing. So you create a second relational component that stores the actual Bevy entity that this unresolved reference should resolve to. Okay, so this is rather than, no, this one has option of an entity ID that comes from LDTK, and this one actually has a Bevy entity inside it. Okay, so then it's going to be, looping over the entities that have this unresolved ref where one was added. And then we loop over the entities that have particular entity IDs. Okay. And then if this component has a mother ID inside it, interesting. So you're resolving this, and then for the entity that is the child, you remove the unresolved thing, and then you insert the resolved. Otherwise, if there is nothing that matches, you just remove that. Okay. Oh no, this is let some. So I think there's a mistake in that first example, that they have an expect there, and there should not be an expect there. Oh no, I'm sorry. Okay, so this expect is saying there should be this field, but that field may or may not contain something. That's what the difference is. So they're expecting this entity it must have this field, but that field could be empty. Hi, Isaac. Yeah, no problem. I did start early today. Welcome to the stream. And I'm about to wrap up, unfortunately. But I think you learned a lot about this library and using LDTK, and I think this is really, really interesting. Um, so we have some stuff to do next time, which will be to put some of the stuff into practice in our survivors game. So things we could do are, let's start over on the level editor. Let's make levels based on the int grid. Maybe do some random selection among the tiles for particular areas. We played with the rule set on these not the layers, on the walls. We played with the rules here. So we could do something like this with our with the tiles that we have in the tiny dungeon tile set, and we can maybe like have a more principled approach to how this is put together. Yeah, so this is kind of neat. I'm glad I learned about how to use these properly, and we'll make better use of it next time. So I think this is a good place to stop. Thank you for coming today, and thank you for participating in the chat. As always, Chris, thank you for your help and your encouragement. And longtime viewers, thanks for coming back. Love to see it. And we'll do more next time. I think we'll be starting to get more productive with this beyond just getting the systems, the mechanics of the game. We can actually get some decent art, and maybe we can make use of the stuff that comes with LDTK to make our systems a lot easier to implement, and that'll be great. So thanks again, everybody, and we'll see you next time.